In this clip, we're going to meet Professor Searl, and very much in the land of living. And if anyone had a brilliant brain and is using it, it's John. Come and join me here in your house.
Hello, Terry.
So,
Glad to see you.
So this is John, the very person behind all this technology, and I'm going to get him a chair and he's going to explain some of the technology to you while I sit and watch. So let's get you a chair.
Thank you.
There we are.
Welcome to my brothers and sisters, wherever you are. I welcome you into my humble home, where I shall attempt to prove or disprove, if the scientists are right, that this technology breaks all the laws of physics. We take a roller, and it's called a roller set because there are actually 8 sections involved in the real SEG. We have the plate, which has already been explained in earlier clips, and if I simply, you see the force involved. That's one. We notice immediately the first one want to find some sort of position balancing to this one. That's 3. Immediately we see they are trying to find some sort of balance. We have 5. Again we notice we have 2 this side. Why? Well, it's because it's a wave on that plate, a wave effect. And this wave, they have to find a position in the trough of it. So as we disturb that position, they immediately got to try to make some adjustment. We don't make the adjustments. You see, again, they're lining up. If we notice, we've still got a stretch of the wave at that point, and we have a stretch of wave at that point. We're watching this carefully, we will see how they adjust themselves. We've got 1 to go in there. That's your 12. They haven't jumped off. There's no jumping off. No, even the slightest interest of jumping off. They are firmly attached to that plate. A very, very thin line of the roller set touches that plate. And they are quite free. We can see that they're not held solid, absolute solid. If we look careful, especially down it, we've seen that they're tending to line up with these points, reference points. That point is the trough of the wave. So we have the wave coming down, climbing, back down, all the way round here. On this plate and on the roller set, there are some waveforms not put on because we need to know what the voltage is required to make them move. That is the problem. On the SUG, it will never stop. That is something we need to know now, because requirements of a patent, they will want to know what the idle speed is. And when they say idle, they mean this. They don't move. Newton says in his law that everything remains in a state unless another force interacts. We are right. The force here and the force here are matching. They are equal, but extremely thin this force is to this force. It does not take much to upset that. Any little force will cause it to move its position. It don't fall off. So we have a force around this plate which has some interference with these points, which would be on another ring on the SUG. There would be this force between that plate and this plate, this emitter and this collector. Here we have what you would call a solid state device, but this is 1946 we are talking about. All we've done now is try to improve the concept for mass production purposes. The old system would take too long to make one of. We must be able to make hundreds per day, and we have to change our thinking. Our thinking now is that if we make layers and press them together, this would be like shelling peas. One round would be chopping out the copper, the other on the delirium, then the plastics or nylon or Teflon, and then the rare earth for the collector, whichever one we use. These could be just run out like tubes and chopped to size, then just quickly touch up with a milling machine, passed to the robot to assemble, to make it very simple, which is different than putting this all together in a mould, and that's a difficult task with rice paper between the different materials to try to keep them separated, and then oscillating it to gradually pull those rice paper rings out so that you can now press. Then the slow rate of pressing which took place meant that the heat generator had to escape. Then we get it down with enough weight on, we've got to hold it. And once it cooled down, we then energize it. This would take 24 hours between the start of the process and the finish of one segment. We'll show you a segment in another cutting. So we have here really a very simple device. Now, if we put on the wave effects of the missing waves, we will see that this, which just don't want, it just wobbles about, will